Welcome to day 1 radical equations for unit 8. So I've posted the schedule for unit 8 on your Google Classroom. It'll be found in your classwork section under the title unit 8. So here for day 1 we need to figure out how to solve for x in radical equations. So I'm going to be very straightforward with this. What we want to do is when you have a radical equation, we want to figure out what x value will make that statement true. So the first thing that we're going to do, I'm going to rewrite it. The first step is to isolate the square root. Okay, we want to make sure that the square root is by itself. Then, how do you unlock a square root? You square it. It's an equation. So if I do something to the left-hand side, I have to do that same thing to the right-hand side. Everything on the right-hand side. The reason why I square a square root is because it takes whatever's underneath and unlocks it. It literally becomes just x. Over here, 2 squared, well, that's 4. So the golden rule of radicals is you are required to check. Okay? It is an absolute must. So there's 2 ways to check. The first way is to do it algebraically. So check when x equals 4. You go back to the original equation and you sub in 4. And you make sure that it works. So the square root of 4, is that 2? Yes, it is. So you say it works and you can accept 4 as your answer. The other way that we check is on Desmos, okay? We all know that an equation can be checked by graphing the left-hand side, okay, equals y, and the right-hand side, which equals y equals 2, okay? Where the 2 points intersect, the x value is what I'm looking for, right? So there's another way to check. You have to check one way or the other. Okay, so let's try equation number 2. Here I have the square root of x. Well, first thing that I see is the square root of something equals a negative. Can a square root of something equal a negative? So the first thing I want to do, I'm going to rewrite the problem. I'm going to square the left-hand side and square the right-hand side, right? I have my radical by itself. It's all alone. I square it, I get an x, right? Everything that's under the radical comes out. When I square negative 3, I get positive 9, right? Negative squared is positive. 3 squared is 9. Well, when we check, because the golden rule applies on every single radical problem, when I sub in x equals 9 into 9, the square root of 9 equals negative 3, can that happen? No. The square root of 9 is just positive 3. Negative 3 and positive 3 do not equal. So sometimes we have to do what's called reject our answers and say no solution. Okay? So, and we can also check that by plugging this in here, right? I have the square root of x already in there. But if I plug in y equals negative 3 is all the way down there. Notice that those 2 graphs, they never intersect, right? That red line just keeps getting further and further away from the green. So sometimes there's going to be equations that don't have solutions, okay? So we say no solution, and no solution is actually our answer, okay? Only a few more. Okay, and what I've got here is the first thing that I notice on example number 3 is that the square root of x plus 9 is not isolated. So that's always our first step. is we want to isolate the radical. We want to get the radical all by itself on one side. So what I'm going to do first is I'm going to add 3 to both sides. When I do that, I get the square root of x plus 9, right? Nothing happens to that, that just comes down. And on the right-hand side, I get negative 2 plus 3. Well, that's positive 1. Then, to unlock the radical, what I want to do is I want to square it. And if I square the left-hand side, I need to square the right-hand side. When I do that, everything that's under the radical, we call this part the radicand, literally just falls out, and it becomes x plus 9. The square of 1 is just 1. Now I'm going to solve this like any other linear equation. Subtract 9 from both sides and get x equals negative 8. Now before I can accept negative 8 as my answer, I must check. I will check both algebraically and graphically to make sure I'm right. Here, I want to sub negative 8 in to the original equation, making sure that negative 3 is outside of my radical. Now, negative 8 goes in to where the x was. Don't forget to use your parentheses. So, PEMDAS states parentheses, exponents, and radicals, multiply, divide, add, subtract. Remember, a radical symbol itself actually groups the numbers underneath. So this is negative 8 plus 9, or 1. Then I subtract 3 equals negative 2. Again, with PEMDAS, radicals go first, so the square root of 1 is 1. 1 minus 3. Does that equal negative 2? I believe it does. Once I've established that that is an appropriate answer, we can accept x equals negative 8 as our solution. Okay. Also, if you can, you have the ability to go onto your calculator. Okay. And it's kind of want it on the left side. There we go. X plus 9 under the radical. Then out of the radical for the minus 3. Plug everything on the left-hand side as if it was one equation, and everything on the right-hand side as if it was another equation, and see if they intersect. They do intersect in this one spot right here at negative 8. Okay, remember we're looking for the x value. Okay? Now, excuse me. So, moving on, one more and then I'll let you go. Sometimes we're going to have a scenario where we don't just have one type of term on the right-hand side. Sometimes we're going to have variables. So what I'm going to do here is first I'm going to rewrite the problem. You want to make sure, just like in the others, that we've isolated the radical. The radical needs to be completely alone on one side. Now, I know that just like in all the others, I want to square the radical once it's completely isolated. That's fine on the left. The only difference now is on the right, it's not just a number like negative 2 or a number like 1. It's actually the entire expression x minus 2 that gets squared. Okay? Now, moving back to the radical quickly, the radicand, this behavior is exactly the same. Right? The radicand just falls out from underneath. However, on the right-hand side, this isn't just an easy breezy thing. We have to actually multiply out what the new expression is. X minus 2 times x minus 2. When we do that, we can do the arc method, or we can do the double distribution method. X times x minus 2 times x minus 2. Whichever way you are comfortable with. Here, the left-hand side is still 8 minus 7x equals x squared minus 2x plus 4. Don't forget to distribute the negative, right? So I get 8 minus 7x equals x squared minus 4x plus 4. Now we have a quadratic. So we always want to get all of the terms on the left, or all the terms on the side where x squared is not. Okay? I didn't say that right. We want all the terms on the side where x squared is positive. Okay? Because most likely we're going to have to factor. So what I want to do is I want to subtract 8, and I'm going to add 7x to both sides. That will give me 0 on the left-hand side. So I get 0 equals x squared, 4x plus 7x is what, positive 3x? And 4 minus 8 is negative 4. Now, we can go ahead and factor this, right? Two things that multiply together to give me negative 4, but add to give me 3. Well, that's 4 and negative 1. So here, 0 equals x plus 4, x minus 1. Okay? I want to use my zero product property and set each of those factors equal to 0 and solve. Negative 4 equals x. And, let's see, add 1, 1 equals x. I cannot accept them as an answer until I check them. So I'm going to use this space over here to check when x equals negative 4. I always want to make sure that I'm subbing into the original equation I was given. That is 8 minus 7 times x. Does that equal x minus 2? And I'm going to sub into those parentheses exactly negative 4 and negative 4 and see if it works. Here, under the parentheses, I have 8 minus 28. Well, does that equal negative 4 minus 2, negative 6? Ooh, that's negative plus. So 8 plus 28, that looks like the square root of 36. Does that equal negative 6? Well, the square root of 36 is positive 6. That definitely does not equal negative 6. So what I have to do is I have to do what's called reject that answer. Okay? That's what we call an extraneous root. Okay? It comes about in the squaring process. Okay? So, the last thing I do need to do is I do need to check that positive 1. Algebraically, it is the square root, again, in the original, and I apologize for the, I'm running out of space here. 8 minus 7 times x. Does that equal x minus 2? So I'm checking when x equals 1. So plug in 1, plug in 1. I get the square root of 8 minus 7, right, which is 1. Does that equal 1 minus 2? Well, looks like the square root of 1, which is 1, does not equal negative 1. We need to reject that one as well. Okay? And when we check it on our Desmos app, okay, what we want to do is we again want to go ahead and plug in our original 8 minus 7x, okay, and what's down here? X minus 2. Again, notice they don't intersect. Okay? If this had been x plus 2, we would have had an answer, right? But unfortunately, it's not. It's x minus 2. And if the graphs don't intersect, then we don't have a solution. So we would say for this one, I'm going to write down here, no solution. Okay, so that's all for today. Have a great day. I'll check in with me if you have any questions. I'll be available Monday, Wednesday, Friday from 10 to 11 a.m. on Google Meet, and I will post the live link in the Google Classroom stream. Have a great day.